This video is going to cover Chapter 5, Section 4, which is sum and difference formulas. So the first preference is all of the actual sum and difference formulas. And yes, this says addition and subtraction. Realize that sum and difference are the same thing. Some books call them addition and subtraction, and sum and difference. So these are your formulas. And this is basically what you need to memorize for the rest of this section, and then we'll learn how to apply it. So for sine, whether it be addition or subtraction, the pattern is sine, cosine, cosine, sine. So if you're trying to find the sine of the sum of two angles, then you would multiply the sine of the first angle times the cosine of the second. If it's plus, the sign matches, so it's plus. Cosine of the first times sine of the second. If it's sine of a difference, the pattern is still the same. It's sine, cosine, cosine, sine. But this time it gets a minus in between. So if it's a minus here, it's a minus here. So you would do sine of the first angle times cosine of the second minus cosine of the first angle times sine of the second. The pattern for cosine is cosine, cosine, sine, sine. So this time the functions are together. And if it's addition, the cosine sum or difference is the opposite. So if it's addition, then it would be subtraction. For the cosine difference, it would be addition. But same pattern, cosine, cosine, sine, sine. So you'd find cosine of the first one times the cosine of the second one. And then the opposite sign. So if it starts plus, it becomes minus. If it starts minus, it becomes plus. Sine of the first one times sine of the second one. And the last trig function, sum difference that we look at is tangent. So tangent is the sum of the two tangents in the top over 1 minus the product of the tangents. So the sign this time, positive, negative, matches your numerator. If it's plus, then the numerator is plus and the denominator is minus. If it starts as a difference, then the numerator is the difference and the denominator is 1 plus the product. So it would be tan minus tan over 1 plus tan times tangent. All right, so now let's see these. Example 1 says, find the exact value of each expression. A is cosine of 120 plus 45. So instead of adding those two in the middle and then finding the cosine of that, we're going to use our sum and difference formulas. Because what may happen is when I add these two, so for example, I'd get 165. And if you remember on your unit circle, 165 is not one of those angles. So without a calculator, you wouldn't be able to get this answer. And even with a calculator, it wouldn't be exact. So we use the sum and difference to find the exact values without needing a calculator. So remember the pattern for cosine is cosine, cosine, sine, sine. So I do cosine of 120 times the cosine of 45. With the cosine, it's the opposite, positive, negative sign. So if it starts positive, then I put a minus between. And then it's sine, sine. Sine of the first one, sine of the second one. So now here's where we bring in our unit circle. So I want to replace these with what they are. The cosine at 120, so if I locate 120 degrees, which is here, the cosine is the x coordinate there, which would be negative 1/2. The cosine at 45, and we know 45, that's our root 2 over 2 and root 2 over 2. So the cosine is root 2 over 2. Minus the sine at 120, so we're back to the 120, but the sine, which is the y, would be root 3 over 2. And then the sine at 45, and we know 45 is root 2 over 2. So now I want to multiply the individual pairs. Negative 1/2 times root 2 over 2 is negative root 2 over 4. And then minus root 3 times root 2 is root 6 over 4. So I simplify this by putting it together under one fraction, negative root 2 minus root 6 all over 4. Now we look at B. There are two differences. One is its sine. The other is that these are now radians, but the same exact process. The pattern for sine is sine, cosine, cosine, sine. So I would do sine of the first, cosine of the second. Whatever sign is in my sine sum or difference is the same when I expand it. So this is a minus. Cosine of the first and sine of the second. Now this time 7 pi over 3 is actually bigger than 2 pi, so it's not on my original unit circle. I know 7 over 3 would be 2 and 1/3 pi, or 2 and pi over 3. The even whole numbers fall to the right, so 2 would go all the way around and it would stop at the next over 3, which is my coordinate point of 1/2 and root 3 over 2. And then the coordinate point at pi over 3 is also the same point, 1/2 and root 3 over 2. So if I simplify this, I'm going to replace sine of 7 pi over 3 with root 3 over 2. Cosine of root pi over 3 with 1/2. Minus cosine of 7 pi over 3, 1/2. And sine of pi over 3, root 3 over 2. Now, what you think should happen. I'd get root 3 over 4 minus root 3 over 4. Because this is the same angle, even though because it's coterminal, it should make sense that that would be 0. This time, you actually could have seen it from my original question. If I simplified this, I'd get 7 pi over 3 minus pi over 3, which is 6 pi over 3. And 6 pi over 3 is 2 pi, which is over here on the right. And the sign there is 0. So it is possible that you can simplify what's inside your parentheses first, but most likely will not happen on your test. You're going to get ones that you're forced to use the unit circle and the sum and difference formula. All right, example 2 says find the exact value of the sine, cosine, and tangent of the angle by using the sum or difference formula. So now the difference is we don't have the breakdown of the two numbers. We have to figure out what that is. And notice it says sum or difference. So you can either find two numbers that when you add them together, you get 105. Or you can find two numbers that when you find their difference, it's 105. So there's more than one way to do this, but the answer should always be the same. So if I look at 105, first of all, because it ends in a 5, I know I'm going to have to involve some sort of a 45-degree angle. So if I were to take away 45 degrees from 105, I'd be left with 60, which tells you that 45 plus 60 would sum to 105. You can also do 135 minus 30 because that would be a difference. That would give you 105. But let's stick to 45 plus 60. Now what it wants you to do is find the sine of this, find the cosine of this, and find the tangent of this. So a quick reminder that the coordinate point at 60 degrees is 1/2 and root 3 over 2. And the coordinate point at 45 degrees is root 2 over 2 and root 2 over 2. So when we look at the sine, remember the pattern for sine is sine, cosine, cosine, sine. I would get the sine of 45 times the cosine of 60 plus, because the sine stays the same, the cosine of 45 times the sine of 60. So sine of 45 is root 2 over 2. Cosine at 60 is 1/2. Cosine at 45 is root 2 over 2. Sine at 60 is root 3 over 2. Multiply your pairs, and I get root 2 over 4 plus root 6 over 4, or root 2 plus root 6 all over 4. So what you may see happen is if we had started in the beginning and said 60 plus 45, the order would just be switched there. It would be root 6 plus root 2 over 4. But it's still the same answer because, again, this is addition. And in addition, the order doesn't matter. Now let's look at cosine. So the pattern for cosine is cosine, cosine, sine, sine. I would do cosine of 45, cosine of 60. The sign changes with cosine, so it becomes minus sine 45. Sine 60. The cosine at 45 is root 2 over 2. The cosine at 60 is 1/2. Sine at 45 is root 2 over 2. Sine at 60 is root 3 over 2. Multiply out your first pair, you get root 2 over 4. Multiply out your next pair, you get root 6 over 4. And I get root 2 minus root 6 all over 4. And then we go to tangent. So tangent, the pattern is tangent of the first. Keep the sign the same in my numerator, so plus tangent of the second. Over 1, change the sign here so it's minus tangent of the first times tangent of the second. So again, refresher on those coordinate points. The 45, your tangent's going to be a positive 1. And the 60, which is your over 3, your tangent's going to be root 3. So now I want to plug those values in. Tangent of 45 is 1, plus tangent of 60 is root 3, over 1 minus tangent of 45 is 1, times tangent at 60, which is root 3. So from here I get 1 plus root 3 over 1 minus root 3. And we can't leave the square root in the denominator. That would be irrational. So we're going to rationalize this by multiplying both the top and the bottom by the conjugate of the bottom, or 1 plus square root 3. So my numerator is 1 plus root 3 plus root 3 plus 3, or 4 plus 2 root 3. And my denominator is 1 plus root 3 minus root 3 minus 3, or negative 2. And then I can go a step further and divide negative 2 into both 4 and positive 2. I end up with negative 2 minus root 3. So I'm going to skip the second example just because hopefully it's the same pattern. What I would say is, and maybe this time it's a little less obvious to figure out what you can add in there. But again, there's a 5 involved, which tells me that there's going to have to be a 45. If I subtract 45 from this, I get 240, which is on my unit circle. So then I can do all the sum and difference with 45 plus 240. I would do the same thing we did on the left. Sine of 45 plus 240, cosine of 45 plus 240, and tangent of 45 plus 240. Okay, example 3 is now the reverse. This is write the expression as the sine, cosine, or tangent of an angle. So what you have to identify from what you're given in the question is which pattern is it? And then based on that, what do I do at those angles? Do I add them or do I subtract them? So when you look at when you look at A, you see cosine, cosine minus sine, sine. Because the pattern is cosine, cosine, sine, sine, that is cosine's formula. And with cosine, we do the opposite sign in between. So because this says minus, this is really the cosine of 25 plus 15, or the cosine of 40 degrees. Now, this just says write the expression. I'm not evaluating it, which is good too, because this is not on your unit circle. So without a calculator, you wouldn't be able to, which means you'd leave it exactly that way. B is obviously tangent. This is the only one that has tangent. And with tangent, you match your numerator sign. So this would be tangent of 2x plus x, or tangent of 3x. Now we're going to take it to the next step. So find the exact value of the expression, rewrite the expression as one function, and then use the unit circle to find the value of that function. Example 4. So again, directions this time say find the exact value of the expression. We're not just rewriting it. A says sine 330 times cosine 30 minus cosine 330 sine 30. The pattern now is sine, cosine, cosine, sine, which is your sine pattern. And then with sine, we match the positive, negative sign in between. So this would be 330 minus 30. This is sine of 300 degrees. So I pulled in the unit circle again, and you can find the 300 degrees, which is down here. And because we're looking for the sine, that's the y coordinate, my answer would be negative root 3 over 2. With B, this is obviously tangent, and remember tangent, we match the sign in the top. So this is tangent of 25 plus 110, which is the tangent of 135 degrees. Go to your unit circle, find 135 degrees, and this is your over 4, so remember the over 4 of tangents is just 1. Or y over x, which is root 2 over 2 over root 2 over 2, which still gives you, 1, sorry, but it's actually negative 1 because one of those signs is positive and one of them is negative. All right, so now we've seen how to use it with a circle. The other way we've solved a lot of the problems in the last chapter and a half is with triangles, with something like this. So this says, suppose that cosine of theta equals negative 3/5 for a quadrant 2 angle theta, and cosine of beta, which is now a different angle, equals 12 over 13 for a quadrant 1 angle beta. Find the exact value of each of the following. So the first thing you want to do is set up your triangles. There are two here because you have two different angles. One, theta, that is in this second quadrant. So I'm moving left and I'm moving up to find my angle. Here's theta. If it's cosine and it's negative 3 over 5, it makes sense that this adjacent side would be the negative 3. Your hypotenuse is going to be positive 5. The missing side is a positive 4. Then you want to set up your second triangle based on beta, which is in the first quadrant. So this time I'm going to the right and I'm going up. And I'm going to put beta there. Cosine is again adjacent, which is 12, over hypotenuse, which is 13, and you're missing the 5. So these were both triples. If they're not triples, you just got to work out to find out whatever the missing side is. Just pay attention to the positive and negative signs. So now A says find the sine of theta. Theta is my blue triangle. Sine would be opposite over hypotenuse, which in that triangle is 4 over 5. Then it says sine of beta. Beta is my pink triangle. Opposite over opposite over hypotenuse is 5 over 13. C says find sine of theta plus beta. So now we're back to our sum and difference formula. Sine is sine of the first, cosine of the second. Keep the positive or negative sign the same. Cosine of the first, sine of the second. So we know sine of theta is 4/5. Cosine of beta is one of the things that was originally given to us, 12/13. Plus cosine of theta, which was originally given to us as negative 3/5. Sine of beta, 5 over 13. Now you're going to multiply out your pairs. 48 over 65 plus a negative 15 over 65. Same denominator, combine your numerators, and you get 33 over 65, which can't be reduced, so that's your answer. Now look at D. It's now cosine of theta plus beta. So remember that cosine pattern is cosine, cosine. So cosine of the first, cosine of the second. With cosine, we change the sign, so it becomes minus sine of the first times sine of the second. Cosine of theta was negative 3/5. Cosine of beta, 12/13. Minus sine of theta, 4/5. And sine of beta, 5/13. Multiply out your pairs. So you get negative 36 over 65 minus 20 over 65. And I get negative 56 over 65. Again, can't be reduced, so that is my answer. Example 6 says, prove the identity. So hopefully this looks familiar. This is actually one of our cofunctions, which we know is sine pi over 2 minus x equals cosine. But what it's asking you to do is actually prove this using your sum and difference formulas. So if I look at the left side of my equation, sine of pi over 2 minus x, that's sine of a difference. So if I use my sum and difference formula for sine, I would get sine of the first, which is pi over 2, cosine of the second, which is x. Keep the positive or negative sign, so it's minus cosine of the first times sine of the second. And we want to show that this equals cosine of x. So while we can't figure out what the cosine or the sine of x is, we do know that pi over 2 is at the top, which is 0, 1. The sine there would be 1. And the cosine there would be 0. So 1 times cosine x is cosine x. And 0 times sine x cancels out your sine x. And I end up with cosine of x equals cosine of x. Our last example is example 7, which says find all the solutions of the equation in the intervals of 0 to 2 pi. And this should be parentheses. So now we're pulling in 5, 3. The last one we were pulling back in 5, 2. Now we're pulling back in 5, 3. This time it says sine of x plus pi minus sine of x plus 1 equals 0. Hopefully you see the sum that's happening here. I want to expand that out. So it's sine, which is sine, cosine, cosine, sine. Sine of the first, cosine of the second. Keep the positive or negative the same. Cosine of the first, sine of the second. Minus sine of x plus 1 equals 0. So sine of x I can't replace, but the cosine of pi, I know pi is on the left, which is negative 1, 0. So I'm going to leave sine of x as sine of x. Cosine of pi is negative 1. Plus cosine of x I have to leave as cosine of x. Sine of pi is 0. Minus sine of x plus 1 equals 0. So I end up with negative sine of x plus 0 would cancel out, minus sine of x plus 1 equals 0. There's 2 negative sine x's, so I get negative 2 sine of x plus 1 equals 0. Now this should look familiar to the things that we were doing in 5, 3. I've got to solve for sine. So I'm going to subtract the 1, divide by negative 2, and I get sine of x equals 1/2. So because it's telling me my interval is restricted from 0 to 2 pi, I'm going to look back on my unit circle, and I'm going to look for all the places in which the sine, which is the y, is positive 1/2. So I know that's going to happen here at pi over 6 and here at 5 pi over 6. At the other over 6's, the sine would be negative 1/2. So my answer here is just pi over 6, and I don't have to add on the plus 2 and pi because it's already restricted, and 5 pi over 6. And there's your answer. So that wraps up sum and difference formulas and Chapter 5, Section 4.